Hi everybody, Simon Whiteley here. I'll try and unmute myself. There we go. Hello everybody, Simon Whiteley here, and welcome to my latest live stream. This is all very exciting. So yes then, today, this afternoon, I want to give you a little bit behind the scenes of this kind of stuff that I do. So I'm getting ready for my next upcoming mastermind, where I'll be talking about cast accident analysis in the context of a maritime accident this time. And I'm in the preparations phase. So I'm essentially working through the official accident report, familiarizing myself with the details and the technical language and the timeline. And then I'm putting together the slide pack ready for delivering the masterclass. And the intention of this live stream was essentially just to share a little bit behind the scenes, give you a little bit more information about CAST and how to apply it, but also give you the behind the scenes and see what it is I'm doing and how I go about preparing for these masterclasses. Now, of course, if you're not already on my email list, please go to systemsafetywebinar.com, sign up, gives your name and your email address, and of course, I'll let you know when the masterclass is ready and when registration formally opens. And of course, keep you informed of any other STAMP STPA CAST related news or events or things that are going on. Now, if we're not already connected on LinkedIn, please visit LinkedIn and send me a connection request. And of course, join my Whiteley-Safety STAMP interest group on Facebook. My intention with Facebook is to do some more of these live streams in that closed audience so that we can talk more openly about things as opposed to as a broadcast on YouTube. And of course, if you're not already a subscriber of my YouTube channel, please remember to hit that subscribe button and smash the bell, as all of the cool kids say nowadays. And as I say, please join my email list so that I can keep you notified of upcoming training and coaching opportunities. So then, CAST accident analysis overview. So as I mentioned, I'm going to be talking about the collision at sea between the USS United States ship Fitzgerald and the motor vessel ACX Crystal, which occurred off the Aizu Peninsula off the coast of Honshu Island, Japan, in June 2017. Now, of course, what I'm going to show you today is work in progress. So this is behind the scenes. So please don't expect it to be all well sharpened and all that, really well put together. Just bear with me. So the objectives of today's live stream really is just to be friendly and open. It is a Sunday night. It is the end of the weekend, and I've been slaving away working on this. So I want to be friendly and open. I also would like to exercise your mind, and I always say this, minds are like parachutes. They only work if they're open. So please, come at this with your mind open. I'd also like to spark your interest. So obviously, if you're watching this, you have at least some level of curiosity, but I'd like to enhance that. And of course, for me personally, I want to practice and prepare. So for me, this is a bit of a practice at, doing live streams, because I think I should do more of them and help, spread the message and help more people. And so I need to get over my, inadequacies in terms of doing live streams and using all of this technology. So I need to practice that. And also the preparation for the masterclass. So I want to go through this case study, go through it in detail so that I can put together a masterclass that really is world-class and that people will want to attend and will rave about. Now, it is a focused working session. I want to give you that look behind the scenes. Hopefully it's not too frightening. And also for you to have a think about whether you can identify opportunities in what I go through today and how that might possibly help you in what you do. And of course, if you want to connect on LinkedIn, social media, or sign up to my email list, I'm of course happy to discuss things, talk about any challenges that you have and how I could possibly help. So the session objectives, just being more specific. By the end of this session, you'll recognize what is meant by a CAST analysis. As I say, we're not going to go into extreme detail on that because this is not the masterclass. This is just behind the scenes, see what's going on. You'll appreciate the core process of a CAST accident analysis. you'll appreciate how to apply CAST as part of an accident analysis, and you'll hopefully recognize the significant opportunity that STAMP CAST presents. And of course, I'll do my best to answer as many stupid, awkward, difficult questions as you have. I mean, obviously this format's a little bit different to what I normally do on live webinars, live sessions, masterclasses. So I do have the live stream YouTube chat window open. There is a little bit of a lag between what's going on here live and what's happening there, but I'll do my best to keep an eye on that and, pick up any questions that you might have. Of course, it's great to have you here. I do appreciate it. But yeah, I'll move on, and if there's any questions, I'll address them as I can do. I must admit, it is a bit weird doing this live, because obviously there's the anxiety with, watching live TV when you were little, Saturday morning go live and strange things would happen, and, it'd be quite embarrassing or whatever. But also there isn't any audience participation at the moment. So that's also a little bit weird, which I'll need to get used to. And it does say at the moment we've got some people watching, but obviously you need to type in the box and say hello, introduce yourselves. So the session outline, give you some context, which I've done. I'll give you a very, very brief overview of CAST accident analysis, the process, and then I'll talk through the work I've done so far, and I'll continue doing some work in this session. So, and then if there is opportunity for Q&A, then I'll do a Q&A. So then, just to give you a little bit more context. So when you're learning CAST accident analysis, well, any of the stamp-based processes, you have to think about the most effective way to learn and practice. Because obviously with an accident investigation, either they're not very, don't come along very often, or when they do, it's, really serious, and you don't necessarily want to be trying new methods out and things like that. And we've got hi, Steve Carpenter. Good to see you. Thanks for coming along on this evening. I'm sure wherever you are, it's probably the middle of the night. So I'm very honored. Great to see you. If you've got any questions, please stick them in the chat. So yeah, so when you're learning and practicing the stamp-based approaches, and particularly CAST, you need to, or I recommend practicing the thinking and the process with existing investigation reports. And there's a few reasons for that, but one of the main ones is you could do with a nice clean-cut set of information, which is typically found in a good investigation report, that you can use as a starting point to set the scene for a real situation that you can then use as a source data for applying the process and practicing the thinking, practicing the process, practicing the modeling, the control structure modeling, and also practice the actual analysis part where you look at the control loops, feedback loops, and the structure of the control structure. But of course, you've got to be mindful that your practice, if you're using existing investigation reports, is based on the output of an investigation, and it's not part of the investigation. So, clearly you're unable to influence the investigation and ask and answer any new questions. And so quite often you'll find that there's questions that you want to ask as part of your CAST accident analysis that you'll never be able to get an answer for. But it should demonstrate to you that the CAST process enables you to ask questions that you just wouldn't necessarily normally think of in your more traditional approach to accident and incident investigation. And of course, I sort of akin it to drinking from a fire hose when you look at an existing investigation report. So as part of a normal investigation, you'll be collecting information, or as the analyst, the accident analyst, you will be receiving information in bits and bobs and putting that together, probably in a short space of time, but you'll be receiving different bits, arranging it to try and understand it. Whereas with an existing investigation report, you've basically got all the information there and thrown onto you. And so if you're reading a 50, 100, 150 page investigation report, and Steve Carpenter's on here now, and he knows exactly what I'm talking about when I refer to the Clapham Junction rail disaster in the UK. The investigation report for that is just mind-boggling. And so practicing with something like that is a bit of a challenge. But if you're very familiar with it, then that won't be so difficult. But if you're not, there's the overhead that has to go into reading the report, understanding the information, and recognizing that what's in the report, the way the report is structured, who's written it, where it was written, when it was written, there may be certain bits of information in there that are just completely missing. And that's either because it was never, the questions that would relate to that information were never asked, or it was just not included in the investigation report for whatever reason. And so when you're doing your cast analysis, you might identify questions and interesting things you want to look at, but you just don't have the information for. And of course, there's the limits of human cognition, especially, when you've had a long day, you're tired, maybe you've had a few beers or something like that. You're not necessarily going to be able to remember all of this information. And that's really why I like using my iPad so much. And two of the software tools I use is Liquid Text and GoodNotes. And I use that because I can review the investigation report and make notes on it. And then when I come back to look at it later on and really distill it and try and understand it and think about it from a CAS perspective, I can use the iPad to capture that information. And you'll see that in a little while. So this is really me showing to you how I practice the CAST process. And this is just an example using maritime, which I'm not familiar with at all, apart from maybe going on a car ferry or something. I don't know much about maritime at all, so please be gentle. Oh yeah, and this just to give you a bit of nostalgia, this fire hose on the water fountain, this is actually in the MIT Stata building in Boston. So if you've been to the MIT workshop, or if you've not and you want to go, you can see that in the entrance to the Stata building. And then on the right-hand side is one of the MIT Cambridge fire trucks. So I'm a bit of a geek. I like interesting vehicles. So I took a photo of it. That's outside the MIT co-op shop in Boston. So yeah, let's talk about CAST now then. So CAST, the ultimate goal is to establish what was the control structure that existed. So we can look at work as done versus work as imagined, and then how and why it allowed or contributed to inadequate control. Now, we're not just talking about failures here or what went wrong. I mean, that's included, but we're also talking about what went right, or what I call dangerous successes. And then, of course, we need to make recommendations as to what changes are necessary to the control structure to enable adequate control, prevent accidents, and have successful recovery from them. So if you wanted CAST accident analysis on one page, this would be it. So this is the process overview. So I talk about all of the stamp-based processes having three broad phases. And the first foundation phase is where you define and document the losses, the associated hazard or hazards, and then the associated high-level safety constraints. And the high-level safety constraints, these are essentially the high-level requirements for your system, your operation, that essentially mitigates or controls those hazards, or mitigates or controls the occurrence of those hazards. And they are the things, they're the requirements that the overall control structure is required to enforce, required to meet. And if it doesn't, clearly that's when an accident can occur. Then there is what I call the modeling phase. And typically this is the part of the process where you create the control structure model based around those high-level safety constraints and those hazards. And then, of course, because this is a CAST accident analysis, it's typically a good idea to create a timeline, so sequence of events model. And that's not necessarily peculiar to CAST. That's something you probably do as part of your existing accident analysis investigation anyway. And then finally, there is what I call the analysis phase. And this is three broad parts. The physical process, so analyzing the physical situation for any equipment or failures or damage. And then analyzing the control structure itself. So looking at the components in that structure and then looking at the structure itself. And then, of course, making recommendations and supporting implementation, if that's part of what you would do as being an accident analyst. So as I mentioned, the first part of the analysis, the actual detail of the analysis is looking at the physical process. So what and what happened. So what items of physical process or equipment controls were in place, what safety related roles and responsibilities they had, what associated safety requirements and constraints, and then any associated hazard mitigations. So those pieces of equipment may be relevant to specific hazard mitigation. And so this is where we essentially document that link. Then we look at whether or what physical failures or contributory interactions occurred. And then we look, the second part, we then look to understand why there were issues, explain it, understand the reasons behind it. And that broadly breaks down into two broad parts, looking at the physical process equipment and controls to see if they were missing or there were flaws or inadequacies of some type, and then documenting associated contextual factors and any relevant context. And then, of course, what other questions should be asked? Now, of course, as part of the early part of your investigation, and not in this case because we're looking at an already written report, but if you're applying this as part of an investigation, you may find that you ask questions at this stage that then get subsequently answered when you're doing the other phases of the process, if you like. But of course, this is not a linear process. You may come round and iterate it as more information is made available and questions are answered. Then we've got the controller or component analysis, which is looking at the components in the control structure, and then the structure analysis. And again, I've tried to make it as clear as I possibly can. So when we're doing the analysis of each components, we're essentially looking at the control loop. So you can see here in the bottom left-hand corner, we've got a very basic high-level control loop model, which I typically refer to as a jigsaw piece. So whenever you're doing a stamp-based analysis, you're essentially playing a game of jigsaws. You're trying to build a jigsaw puzzle by identifying the jigsaw pieces and how they fit together in a hierarchy. So the first thing to do is document safety-related roles and responsibilities and any safety requirements, constraints. Then look for control and feedback ability to see if there was any actuators or sensor failures. Now, of course, when you're looking at the physical process level, it's quite easy to identify actuator and sensor failures. But if you're then looking at the higher levels of the hierarchy, such as where individual people or teams or departments in organizations are interacting, clearly actuators and sensors is a bit of an abstract concept. So it depends on the specifics of what you're looking at. I mean, a silly example might be somebody sends an email to the higher up management organization and it doesn't get through because the IT is broken or the network is down. So from that high level organization perspective, they've not received that feedback because of a failure with their sensory, the sensor feedback channel. Then we look at the contributory control actions, so both from a component perspective, but also across the system, so interactions. So if there is a control action from up on high, which has not reached that particular controller, we can start to identify that kind of stuff and recognize we'll need to analyze that when we look at the structure aspects, the structure analysis. Then we explain the actions and behaviors the best that we can with the available evidence. So were there any mental model or process model flaws? If there were, why was that? Contextual factors, and especially for humans, the context within which decisions were made. So if they were making decisions based on out-of-date information or information they believed to be true but actually wasn't, then that's where we would identify it. And then, of course, document any other questions that we need to ask as part of the investigation. Now, of course, it's important to recognize that when we're doing a cast accident analysis as opposed to an STPA analysis, we're doing it after the fact, after the event has occurred. And it may be that we're not able to collect evidence to give us the same level of confidence or detail that we would be able to gain if we were doing an STPA hazard analysis. So I'm sort of focusing here on the contributory control actions here. We may be able to identify whether a control action was not provided, was provided, the timing and sequence or duration was at fault, but we may not be able to get certainty on that. So there is a difference there between STPA and CAST. CAST is a very powerful tool, but we're not necessarily going to get to the same level of detail as we perhaps would with an STPA hazard analysis. And then, of course, we can recognize work as imagined versus work as done explicitly. And then once we've done that, we can move into structure analysis. Now, I've sort of implied that it's a bit of a flow: physical analysis, component analysis, structure analysis. Depending on the investigation that you're part of and the analysis that you're doing and the availability of information, you may switch between any of those three and perhaps generate questions in one part of the analysis that can be answered in another part of the analysis. So let's talk about structure analysis. So there are 6 broad areas to consider, but that is by no means a complete list. So of course, when you're doing your analysis, be mindful of other topics that are outside of these 6 that you want to consider. So there is the actual structure of the control structure itself, its architecture, and then the interactions, communication and coordination across the control structure between components, between controllers, dynamics and changes or evolution over time, the concept of a safety management system. So what is the formal safety management system in place in an organization that is intended to control these risks and hazards and losses that we're interested in? And what is the safety information system? So if there is, frontline issues, how does that information find its way into higher levels of the control structure such that senior level organizational members can make decisions from a strategic as opposed to a tactical level? And then, of course, everyone's favorite, safety culture. And then what other questions should be asked? So there we go. So in a nutshell, that is a CAST accident analysis. I'll just quickly talk about contributory control actions and unsafe control actions. So when you're doing an accident investigation, clearly you can't mind read the people that were involved. So you can't necessarily know. You might be able to get evidence, but you can't necessarily know for certain why they decided to behave in the way that they did. So this, why did they take a particular action, for example? And generally, from a safety perspective, there's an underlying assumption that most people don't come to work to kill themselves or kill other people. And so when they take action or don't take action, it's likely to be in that frame. So if they do take some actions and it results in an accident, it's not appropriate or fair to judge their behavior as unsafe, because they may have been acting on the best available information at the time. And so they believed what action they were taking was appropriate and would lead to a safe outcome. It's just due to other circumstances on this occasion, it resulted in an accident. And so just to highlight, when we're doing an STPA hazard analysis, we talk about control actions from a controller in the context of unsafe. We know from the design perspective that a certain action at a certain time in a certain context will lead to an accident. And so we can label them as unsafe control actions. But when we're doing a CAST accident analysis and looking backwards in time with the benefit of hindsight, it's not appropriate to call those control actions that result in an accident unsafe. We have to refer to them as contributory control actions. So conceptually, they're the same thing. It's just the way that we talk about them. We have to be mindful of our potential for hindsight bias and unfair judgment of people. Quite often you hear as part of an investigation or news reports that people were stupid. Oh, it was a stupid person, that's why they did that. It's all human error. And that's not helpful. By talking about things like that and treating people in that way, being overly judgmental, not only are we not learning from the investigation as much as we could, we may miss opportunities to make the system safer and prevent future accidents. So we do need to be mindful of what we're saying and how we're thinking about it. So when we're talking about contributory control actions, as I mentioned, there's 4 general types. So there is the first, which is a control action required for safety is not provided. An unsafe control action is provided. A potentially safe control action is provided too early or too late or at the wrong time or in the wrong sequence, so timing or sequence. And then a control action required for safety is stopped too soon or applied too long. Now, also, when you're doing any kind of stamp-based analysis, you need to think in your mind, what is the basic control structure model? What type of functions will exist in our control structure? And this picture here is just to represent how an investigation team will essentially form part of that control feedback loop. So on the right-hand side, we've got some investigators. You'll have a lead investigator. You'll have some subject matter experts. If you're trying cast out or really getting good results with cast, you're likely to have a cast facilitator to try and help steer people in terms of applying the cast process. And then, of course, you'll have some kind of organization management. And that organization management, dependent upon the industry and what it is you're actually looking at, they will be focused on the operations part of running an organization, but also there'll be elements of design work going on. So thinking about how we, change the organization to manage competition or improvements to our process to reduce costs, lean, for example. And so in that organization, you'll conceptually have two types of thinking going on. You'll have operations thinking, trying to make the system work reliably, dependably, and make a good profit or be successful in whatever it is. And then you'll have some level of design thinking or change thinking, change management. And that can have quite a significant, drastic, often implicit effect on the overall business or operation that can contribute to accidents. And then, of course, we've got the actual, business of the business, if you like. So working in the business as opposed to on the business or organization. So working in the business, we have the control process. So that is, in the case of the Navy ships, this is the ships themselves and the mission that they're performing and where they are, what they're doing. You've got the maintenance control structure, the operations control structure, and as I mentioned, design, which might be change or modification or introduction of new systems, for example, new processes. And then, of course, response and recovery. And response and recovery is, logically, it's there, but often it's not designed or thought about in too much detail. And I'll talk a bit more about that as we go forward this evening. So then, definition of a hazard. So just to be clear with everybody, whenever we're doing a stamp-based safety assessment or an accident analysis using CAST, we are talking and thinking about hazards in this context, this definition. So we're not talking about the generic definition of a hazard that is very popular, and personally it's very frustrating, where we think of literally anything that has the potential to cause harm. And having that definition, whilst it might be easy for people who are not necessarily involved in this type of engineering or investigation to talk about, but it actually means that there's too much to deal with. You're trying to manage literally everything, and you don't necessarily have enough time or resources or energy to do that. So Stamp, Nancy Levison and a team have effectively constrained that definition to something that's actually meaningful. And so when we talk about Stamp, just be mindful, we're talking about hazard as defined here. So this is a system state or set of conditions that, together with specific environmental conditions, can lead to an accident or loss. So let me just sort of, describe that a little bit more. So we're thinking about conditions or states or events that exist in time limited. And we're talking about the relationship between the perspective of the designer or operator and the thing that they're interested in, the system that they're interested in, and the states and events that system can be in. And then, of course, the interaction between that system, state, or events and some form of environmental state or event. And I'm not necessarily talking about, a ship at sea and the environment as in the sea and the weather. I'm talking about the broader concept of environment. So it will include the weather and stuff like that, but it'll also include other people or other systems. Like in this case, we're talking about two ships in the huge ocean. sailing around doing whatever they need to do. And it so happens that they've come to interact, and that's what's resulted in a loss. So when we're talking about the designer or operator perspective, we're not necessarily referring to the designer and operator of a Navy ship and the designer operator of a civilian ship. We're talking sort of holistically, from that perspective of designer and operator. So what is the system? What are the states or events that we're interested in? And how does the environment, state, or event contribute to an accident? So I've actually modified some worksheets that I've developed over the last couple of years. And I'll be using these worksheets this evening because I find it helps me to organize my understanding, organize the information, and help me get a clearer picture of actually what's happened, what information is relevant to a cast accident analysis, how I can build the control structure in the most effective way, and then how to conduct the analysis itself. So as I mentioned, there is the foundation phase, so I've got a worksheet for that. There is the modeling phase, where you have a control structure model and a timeline. And then the analysis phase, so physical process analysis, component analysis, and structure analysis. Now, of course, it's important to recognize that the more complex your control structure is, the more time it's going to take to do the analysis, but also that for the component analysis, I'd recommend doing one worksheet per component. But then when you start thinking about interactions between components, such as officers on the deck of a ship, it may help to bring those different component analysis together on the same page so you can see where the changes in people's mental models have occurred and where interactions have occurred or not. And that has contributed to an accident. So if you imagine that, the Tenerife disaster, I'm very familiar with that. The captain of the KLM aircraft that took off and subsequently collided with the other 747, his mental model was clearly that the runway is clear and so it is safe to take off. Whereas his mental model was not updated by the Pan American crew talking on the radio because there was a squelch in the radio frequency. So his mental model was not updated to realize that there was an aircraft still on the deck. And so, as I say, if you put the analysis of components on the same page through a time sequence, you can see where those interactions exist. So let's talk about the case study collision at sea. So as I mentioned, this was off Aizu Peninsula, Honshu Island, Japan, in June 2017. I apologize if I've not pronounced that correctly. And I've used, as I normally do, I use a single source of information. In this case, it's the official National Transportation Safety Board investigation report, MAR 2002. It's 50 pages long. It's not that long. It's available at that link. There is some other related information. So there is the accident report detail, and then the safety recommendations, and then the public docket. So the public docket is like an online database with the evidence that was collected as part of the investigation uploaded to that docket. So you can look at the official investigation report and the associated information that goes with it. It's quite helpful. So what happened then? So this was a collision at sea. It occurred on Saturday morning, the 17th of June, 2017, at 01:30 local time. Excuse me. The weather environmental conditions, it was cloudy skies, but there was 10 miles visibility with the sea state 1 to 2. If you don't know what sea state is, it's essentially the height of the waves dependent upon the wind and conditions. So a sea state 2 is about, I think it's about 3 feet, something like that. So they're not particularly big waves. And in this case, there was 2 vessels involved. There was the USS Fitzgerald, DDG 62, which was a US Navy, or is a US Navy Arleigh Burke class destroyer, 8,400 metric tons with 315 people on board. And then the other vessel was the MV ACX Crystal, which was a large container ship operated by Sequest Ship Management Incorporated from the Philippines. And that was 51,762 metric tons with 21 people on board. Now, unfortunately, There were 7 fatalities on board the USS Fitzgerald, very sad. And the accident resulted in tens of millions of dollars of damage in terms of the ship, the Navy ship damage, but also in terms of the repairs that were necessary and the subsequent issues with getting the ship repaired and put back into service. So it was, you know, an expensive situation. So this is an animation which I'm hoping should look good on the screen. So this is the track trajectory of the 2 ships on the morning of the 17th of June. So this was 1:20 in the morning, and you can see there's quite a few ships. It was a busy part of the ocean with a lot of vessels, a lot of traffic. And you can see the USS Fitzgerald in the top right-hand corner coming down from the north towards the south, and then the ACX Crystal going from the west towards the east. And the black and blue are the trajectories of those 2 ships, as I'm sure you can see from the key. So you can see that the ACX Crystal essentially turned into the USS Fitzgerald, but they were almost continuously on a collision course anyway from very far out, from 15, 20 minutes out. Hi, Christoph. Good to see you. Just sneaked into the live stream. That's amazing. Yes, Steve, blame is the enemy of safety. Absolutely. Yes, absolutely. If you're seeking to assign blame as part of an investigation, as part of analysis, you're going to miss things that could save lives in the future. So the first thing should not be about seeking blame. It's to learn what happened and why it happened so that we can make changes to the control structure and prevent it from happening again. Now, in my research for this particular accident, it transpires there's been quite a few of these. There's been another US Navy ship, I think it was the John McCain or something like that, very similar circumstances. I've not looked at that in detail because I don't want to corrupt what I understand about this, so that I can get a clean analysis and understanding to practice the process. And then once I've practiced the process and got some results, I can then go and see if any of the unanswered questions I generate are actually answered elsewhere. So yeah, this is a picture of the damage. I mean, this is shocking. So the Fitzgerald was hit on the starboard side by the bow and the front port corner. I was going to say near side corner, but that's not applicable for ships. So I don't know too much about maritime, so I apologize. But you can see the impact on above the waterline was substantial, but the bow, this bulbous bow on the ACX Crystal impacted below the waterline and penetrated the ship. So there was considerable risk of this ship sinking, considering that there's a big hole in the side. I understand that some of the crew that were lost were in their cabins in that area. And also I think the captain was also injured when the penetration occurred. But as I say, I've only read part of the investigation report because I don't want to spoil the opportunity to learn as much as I can about applying CAST with this information. Because once I've applied CAST and got some results, I can step back and look at where I found things that weren't necessarily in the official investigation report. Okay, so obviously there's a timeline. I typically stick a timeline in these. This one is not the timeline for this accident because I haven't put it in a nice formatted table yet. I need to do that. But I have captured the timeline inside the software on my iPad. So yeah, that's sort of the start of the introduction. How long have we been rolling there? So that's 40 minutes. Okay, so before we continue, as I said, if you're not already on my email list so that I can notify you about the upcoming masterclass, please visit systemsafetywebinar.com, type in your name and your email address, register your interest, and I'll be sure to send an email to you when the masterclass opens for registration. And I'll talk about this, this particular accident in more detail. Hi, Sean. Great to see you. Thanks for coming on to the live stream. It's awesome to see you all here. It's brilliant. Thank you. And then, of course, as I said, if we're not already connected, I think we already are connected. But if you're not already a subscriber of the YouTube channel, please smash that subscribe button and smash the bell, as all the popular people say. And if you're not also a member of my Whiteley-Safety Stamp Interest group, please visit that link and sign up. Okay, so I'm going to switch to the iPad and liquid text now. So I'm going to be bending down, looking at the screen a lot. So I apologize for, blinding you with the light off of my head, but just bear with me a second. Right then. So let's see if I can get the iPad up without breaking anything. So stand by, stand by. There we go. So hopefully that's working. Let's just have a look in the chat, see if there's anything going on. So we've got a few people watching now. Have you all got your drinks? I know it's Sunday night. Got myself a nice Slovak beer called Zlatý Bažant. Very nice. Highly recommend it. I'm not an alcoholic or anything. I don't drink all the time, but it is Sunday. And it's Thirsty Work talking. Right then, so I'm hoping this is coming up on the screen now. There we go, excellent. So this thing you see in front of us is liquid text, and it's on my iPad Pro. And it is essentially a tool that I've used for 3 or 4 years now to review documents, PDF reports, books, things like that. And it allows you to capture in a workspace information. So you can see here that I've been quite busy. So I've read the report. Well, I haven't read all of it. I'll come back to that in a moment. But I've read the report, extracted pertinent information for my knowledge and understanding of the accident. And of course, I'm not a maritime, I've not done a lot of maritime work, so I can't, profess to be an expert in it. But as I've gone through this, it helps me to learn the information, learn the topic. It helps me to take notes. So you can see here these sort of gold, yellow color items. Excuse me, this is timeline related information. So, I said I've not done my timeline yet. I'll basically take this and turn it into my timeline. I'm zooming in, just hoping, looking on the live stream, that it's a good size and that you can read it. Okay. So yeah, so that's the timeline. As I've gone through the report, I've effectively extracted information from the report and put it into the timeline, just arranged it. Obviously, as you learn more and take more notes, things get a little bit messy. But essentially, this tool is very useful for this kind of thing. Learning and practicing is very useful. I mean, you can do it manually with a printout report and some post-it notes and a pen and a piece of paper, but I find this very useful. So essentially what I did to practice, to learn, is take the official investigation report, the 50-page PDF I mentioned, and essentially walk through the report, reading relevant information, but also to not ruin the surprise, for want of a better word, of doing the cast analysis, identifying recommendations and questions that need to be answered, and then seeing if they are the same conclusions in the official recommendations, or if there's anything else extra that I've identified that's not mentioned in the report, either because it's been excluded for whatever reason, or because it was never identified in the official investigation. So what I've done is read parts of the report. So the factual information, I've read all of that. The analysis section, I've read the first couple of lines, but I've not read the rest of it, because as I say, I want to do my cast analysis of that same information and then see how that compares to what's in the actual analysis section. And then if there's any extra information or facts in the analysis section, I can then read those across back into my cast accident analysis. And then, of course, conclusions and recommendations. Now, this report is similar in structure to the ICAO Annex 13 air accident investigation reports, which I'm used to and highly recommend that structure. So it's similar to that, but it's not quite to the same level of detail for whatever reason. Okay, so let's have a look. So, so one of the things I always like to sort of point out, when you're doing your investigations, doing your analysis, or doing your practice of doing CAST, it's always helpful just to have a quick flick through the acronyms and abbreviations, because what I find, especially with military stuff and space stuff, there are always lots of acronyms, and they refer to people or organizations or teams or functions or systems, technical subsystems. And so it's a good idea just to have a quick read through, because some of these items may actually form part of your control structure model. And so I'll pick on one straight away. AIS, Automatic Identification System. That is certainly important, relevant to the control structure and the analysis of this particular accident, as is the CIC, Combat Information Center, the commanding officer, CO, the collision regulations, that's interesting, relevant. I've not looked at those yet, and I need to do that to familiarize myself. But I think they are relevant because obviously we're talking about an accident which was a collision between two ships. So obviously the collision regulations will be relevant. So I'll need to look at that later on. ECDIS, Electronic Chart Display and Information System, that's certainly relevant. Let's have a look. GPS, Global Positioning System, that might be relevant. IMO, International Maritime Organization. In terms of the control structure model, the IMO, if it's necessary to build the model that far, will logically be somewhere near the top if that's how you structure your control structures. Junior Officer of the Deck, Jude, presumably. Yeah, Maneuvering Board, MO Board. So as I said, I don't know too much about maritime, but I'm pretty sure that sounds like it relates to the control of movement of the ship. So that would be interesting. Officer of the Deck, PQS, Personal Qualification Standards. So that will have some kind of implication for control algorithms and mental models and skills and abilities of the crew on board the Navy ship. I don't know the details. SMS, Safety Management System, very generic. SOLAS, Safety of Life at Sea, that might be relevant. Standard Organization Regulations of the Navy. Seafarers Training, Certification and Watchkeeping Code, yeah, again, that might be interesting. Voyage Data Recorder, possibly. Voyage Management System, possibly. VHF, so presumably radio. So if these two ships were not able to communicate with each other, if they attempted to communicate with each other, that may be relevant. And then Executive Officer. So just having a quick look at that 1 1/4 page acronyms and abbreviations, that gives you some idea of what type of things may be relevant to your analysis and your control structure model. So executive summary. So you'll notice that I've blacked some of this out, and that's because I don't want to see the recommendations and findings up front. I don't want to poison my analysis, as I've already said about 1,000,000 times. I apologize. So let's just go back to here. And if you're not familiar with it, I'll just read it out. So the accident summary, about 1:30 local time on June 17th, Fitzgerald with 315 people on board was southbound at a speed of about 22.1 knots after departing the US Navy base at Yokosuka, Japan, bound for the Philippines. The Philippine flag container ship ACX Crystal, operated by Sequest Ship Management with 20 crew members on board, was east-northeast bound at a speed of about 18.5 knots, headed to Tokyo from Nagoya, Japan. As the distance between the two ships continuously decreased, neither vessel radioed the other, That's interesting. So if we're thinking about control actions, that could be considered potentially as a control action not provided when required. But we don't know the detail yet, so we're just speculating. Seconds before the collision, the watch officers attempted to maneuver the vessels to avoid impact. So they did attempt control actions to save the day, but the actions were too late. So control action provided too late, and the ships collided. 7 Fitzgerald members died. Crew members died in the accident, and 3 crew members suffered serious injuries. I think one of those was the captain. The destroyer, sorry, the commanding officer, as opposed to the captain. The destroyer sustained extensive damage to its forward starboard side. The ACX crystal sustained damage to its bow. No injuries were reported. Okay, interesting. So just to sort of highlight, when I'm using this software, one of the things I do is I use a bit of a color code. And I've not standardized it yet because I haven't practiced it enough. But generally, I use the gold or dark yellowy color to highlight time information. So like I showed you earlier on, I'll use it to highlight time. So if it's relevant, I can go and look at it. It's just so that I don't know what information is relevant yet. So I'm taking the information, processing it, putting it in a form that I understand, that I can appeal back to, and then I'll use some of that information later on as we get into the detail of the analysis. I also use this pink or purple color to highlight candidates for entry into the control structure. So this is a US Navy ship. So it's possible that the US Navy, will need to be analyzed in terms of the control structure and their behaviors and feedback. And then again, Philippine flag carrier. I don't know if that's relevant at this time because I don't know too much about maritime, but in air transport, in civil aerospace, for example, the fact that an aircraft is, the country of operation or country of design is relevant to the regulations and to standards that they use, I'm logically thinking, well, if it's Philippine flag ship in this case, what control structure items or interactions might be relevant in the context of it being a Philippine flag ship as opposed to a US Navy ship. And then the red is just to highlight the ultimate outcome, that the ships collided. In terms of the investigation, if you're not familiar with this, the United States National Transportation Safety Board was the lead federal agency in this investigation, and they delegated their authority to the United States Coast Guard to go and gather documents, gather information, and perform interviews on behalf of the NTSB. And then the NTSB did the analysis and probable cause based on the evidence gathered by the Coast Guard, and then additional documentation provided by the US Navy. So yeah, that's sort of the introduction then. I'm just looking at the clock. I'm just wondering if we should have a bit of a momentary break there. So a bit of a comfort break. So I think that'd be a good idea. So I'm just going to shut the camera off and the audio off. I'll just pop out and then I'll be back in a moment. So please just bear with me. Right, I'm back. Now, where's that button to turn the camera back on? Stand by. There we go. There we go. It works. Look at that. Smart. Right, are we all still there? We all having a good time? Everyone got a beer? Okay, so I hope that first part of the introduction sort of helps cement some of the ideas and also give you some ideas for how you can learn and practice yourself. Because it is, learning and practicing the stamp-based analyses, it's all right reading the books, it's all right reading all the information that's available and watching videos and stuff, but really you have to try and have a go yourself. And it's sort of been pointed out to me that that really people need to take action to get benefit from it. And even if it's imperfect action, just take some action, read a report, have a think about the process, try and build yourself a control structure model, and see what analysis, what results you can get from that model. I wouldn't necessarily say, spend a lot of time beating yourself up about trying to understand what a loss is or a hazard or a high level safety constraint. Been quite frank, for an accident analysis, that stuff is not really that important. What is important is your control structure model and the timeline. And then once you've got your control structure model, even if it's a basic one, in this case, it's literally 2 vessels under the control of some crew, and the concepts, the physical processes, the loss of safe separation related to trajectories and movement. So movement control, trajectory control, and the feedback in that loop. So it's a very high level, very simple control structure. And then once we've got that high level, simple control structure, we can start to ask more questions. We can start to ask, why did people behave in this way? What was the training? What was the regulations? What was the standards? Where did they come from? Were they adequate? And we can build on it from there. But really just start with a very simple control structure. Don't worry too much about all of the other complexity and things. Just have a go, dive in. And if you want to have a chat, if you would like some help, please just send me an email, get in touch, and I'll help you as best I can. So then let's go through the investigation report a bit then. So let's just move that up a little bit. So I'm not going to go through the factual information here too much because I want to give you an overview, and then I actually want to do some detailed work and see where I can get to. So this is the USS Fitzgerald DDG-62. This is the location, so southern Japan. Just looking at the live stream, see how big that is, whether it's big enough on the screen. So Sagami Nada, off the Aizu Peninsula, if I've said that properly. Excuse me. This is interesting, actually. So this is a organization chart for the hierarchy in the Fitzgerald. And you'll notice that it's just an officer of the deck with a quartermaster of the watch, junior officer of the deck, conning officer, boatswain, mate of the watch, helmsman, and they report into each other, and that's how they're structured. Now, the thing to point out is this is very different to a formal control structure model. And this structure isn't necessarily designed or structured in the most safety-related, safety-appropriate way. Whereas when we build a control structure model and start to look at this, if we have enough information from the report, we'll start to see what functions and mission, functions and purposes each of these people perform, or each of these roles perform. Who's responsible for, watching what's going on outside the ship, who's responsible for looking after the sensors, who's responsible for giving orders, who's responsible for executing orders and making sure that they're effective. So that's a good starting point to think about the control structure, but just be mindful that this may appear to be a control structure, but it's actually not, not designed or intended for that purpose. We've got some descriptions of the various roles on board. We've got another organization chart. This one is for the CIC, which I believe is the, I was going to look really cool then and remember, but I can't, hang on. CIC, what does that stand for? We saw that earlier. Internal room, yes, I know that. It's in the acronym list, isn't it? Why don't you just go there, Simon? Combat Information Center, that's it. Yes, I remember now. Right, so Combat Information Center. Here's the other ship. So this is the ACX Crystal. It's a huge container ship, bigger than the USS Fitzgerald. And you can see in this picture the actual damage. If I can use use my pencil, just in that area, you can see all the dent. And you can't actually see the huge bulbous bow underneath. So we've got detail about the accident. In fact, actually, this detail about the accident, I might just touch on that because it's relevant. So the first thing to notice, I mentioned AIS earlier on, Automatic Identification System. So the Fitzgerald was equipped with an AIS, but was not transmitting the data to the other vessels as per Navy practice. So it's, when I was talking about control actions, so not transmitting data to other vessels is a control action not provided, or sensor feedback not provided. But that was due to Navy standard practice at the time of the accident. So there are questions there. That explains why the AIS was not being used. But then the question logically up the control structure is, well, who created the Navy practice and how was that Navy practice considered from a safety perspective? And if it was considered from a safety perspective, then, you know, was this actually an acceptable level of risk associated with operating without using AIS? So yeah. So let's move down a bit more. These are some of the radar plots. So this one, you can see the Fitzgerald. Interestingly, there are other traffic in the vicinity, which is interesting from somebody observing traffic and monitoring traffic and their mental model, their process model of the traffic around the ship. They have to be clear identifying which ships are which and what trajectories they're on. If it's difficult to tell or identify, that can lead to issues with their process mental models, which will affect their ability to give appropriate control actions at the time. So just to sort of emphasize that, these two pictures are process models, and they are captured on a technical system, which is presumably read by some human crew, and that will inform their mental model and then how they act and how they behave. So then let's have a look further down. So this is the track. You saw this a little bit earlier on, so I won't labor it too much. There we go. So at 1:30 a.m., 32 seconds, the Fitzgerald traveling at 22 knots and the ACX Crystal at 18.4 knots collided. 7 crew members trapped in their berthing compartment perished, and that's the damage to the Fitzgerald. It's incredible. Excuse me. And then you've seen this picture already, so I won't labor that. So in terms of navigation equipment, there's some information there about the equipment on board the Fitzgerald. There's a dedicated laptop there mentioning about the AIS. Oh, there we go. That's interesting. So these green ones. So these are interesting, what I would call success information, success-related information. So the Fitzgerald crew members reported that the propulsion and steering systems of the destroyer were operating properly prior to the collision. So if you're thinking about the control structure in terms of how the ship controls its trajectory and movement, that is evidence, well, a report that propulsion and steering systems were operating properly prior to the collision. So that indicates that that part of the physical part of the control structure, there was no issue for the Fitzgerald. And then let's have a look at the ACX Crystal. So the AIS was transmitting and receiving information at the time of the accident. So that's interesting, because that information has been provided, that control action has been provided. But the question, the logical question is, well, was that actually received on board the Fitzgerald, and was that information available to crew members to update their process model, their mental model? So that's one of the unanswered, at this stage of looking at this information, that's one of the questions we will document and then look to answer later on. ACX Crystal crew members reported that the propulsion and steering systems of the container ship were operating properly prior to the collision. So again, that part of the control structure, apparently according to this, was fine. There was no failures, no issues. So then there's a section about organizational guidelines. So this is how the Fitzgerald is expected to be operated. So from work as imagined perspective, operational risk management, that's actually something interesting I'd like to look at later on, because there's something interesting in the public docket I mentioned on the NTSB website. There is a load of files and evidence you can download, and one of them talks about ORM, and it might be worth looking at that in detail later on. ACX Crystal, Masters Standing Orders, Masters Night Orders, Safety Management Manual, Personnel, Commanding Officer, XO, Executive Officer, ACX Crystal, Crew, Master, Second Officer. So you'll notice these pink blobs, pink colors. It's just so that I can see where they might appear later on in the control structure model that I want to create. Manning levels. The screen seems a little bit slow. Is that right? Why is the screen not responding at the same speed? Come on. What's wrong with you? There we go. It's working again. So Manning levels, Fitzgerald, some red stuff there. As I said, the red is just because it's relevant information I'd like to look at in more detail. I think it's relevant to the analysis. ACX Crystal. And then section 1.7 is work rest history. So this, from a controller component analysis perspective, this will indicate context about their actions or inactions of people. So if they're fatigued, that is some important context that will affect their ability to make decisions, ability to maintain mental models, and perhaps communicate and coordinate and execute actions. Waterway information. So this is just about the physical vicinity. One of the interesting things is there's this National Geospatial Intelligence Agency, NGIA. They have a planning guide for US sailing directions for the Pacific Ocean and Southeast Asia. And inside that information, it's highlighted that this waterway is noted for its heavy traffic and frequent collisions. So that information is available. The question is, well, did that information find its way down to the operational decision-making of the crew on board this ship? And if it didn't, then why was that? And if it did, why did it not make any, well, why did it not, or if it did, be considered, was it adequate enough to change anybody's decision, potentially change anybody's decision-making? And then environmental information. So I just highlighted visibility on the morning of the accident was good. And yeah, so that's section 1.9. And then we're in section 2 about the analysis. And I've not gone through this section in detail, as you can see. I've not made any notes on it. I've not read it. And then we've got section 3, conclusions, findings, probable cause. I've blacked those out because I don't want to contaminate my analysis. And then some recommendations. Again, I've not looked at those. I mean, just interestingly, that is one page of recommendations. One is to US Navy, one is to Sequest Ship Management. So those two members will likely appear in, well, they will appear in the control structure, but it's just notable that there is only one page of recommendations, I'm sort of, okay, I'm sure there's more we could learn from this. And that's what the point of this activity is. It's to learn and practice CAST. But if there's anything relevant that we find that we should communicate, I'll need to communicate these to the NTSB and see whether they're interested in considering it. Okay, right, so where do we want to start? So what I'll do is I'll just sort of show you this sort of starting point. In fact, actually, let me just, let me pause the share there. Right, there we go. Resume share. So this is some of the worksheets I've got. It's a bit small on the screen probably. So let's just zoom in a bit. So these are just templates I've created, A3 pages as opposed to A4. So you've got plenty of room. Essentially, they're just, so this is the foundation phase. So we've got the losses, we'll list the losses in there. We've got hazards. Remember what I said about the concept and definition of hazard that we use as part of STAMP. It's constrained compared to others' definitions. Then there is the high-level safety constraints. And these are the things that the control structure must enforce. Now, I've already gone through and documented those, so just bear with me, pause. Resume. So I've listed a section called outcomes. So these are just bits of information that was pulled out. Clearly, if you're just doing a safety investigation, you'll be focusing on death and injuries and damage to property, loss of property. But you may also consider the economic or perhaps even media brand impact of this type of situation. So we've got 7 Fitzgerald sailors died, 3 were injured. The destroyer sustained more than $300 million in damage. I need to update my slides. Extensive damage to its forward starboard side. The ACX crystal's bow, penetrated the Fitzgerald's hull and superstructure, trapping numerous crew members aboard the destroyer, and the vessel took on a 7-degree list. They needed to control the flooding, assist injured crew, and search for the missing. 7 crew members trapped in their berthing compartment perished. And I've just asked a question there straight away. Why were they trapped in their berthing compartment and why did they die? Are there questions there about the design of the ship, perhaps? So if the ship suffers a collision, is it appropriate that the crew members are on the outside of the ship? Now, obviously, I know nothing about maritime design or naval architecture or anything like that, so there may be some very good reasons for that. But that's the kind of question that you could start to, okay, what about? On the other ship, on the ACX Crystal, no one was injured. The vessel sustained damage to its bow, sustained damage to its bow and forward compartments. Penetrations to the hull were above the waterline. Cost to repair the ACX Crystal was not reported to investigators. And then also no pollution was reported. Now, this one's an interesting one because I think in the Seychelles, I think somewhere nice and exotic, there was a recent ship collision or run aground grounding that resulted in lots of, I think it was oil being released and making a serious mess, causing a lot of damage and destruction. And I think that's not only is the immediate accident a problem, but also the knock-on effects, longer-term effects to the environment and plant and animal life, and then also the economy of that community. I think they do a lot of tourism, and obviously if it's been polluted, nobody's want to go there for holidays and tourism and such like. Okay, so outcomes, so they are the losses, if you like. as I said, dependent upon the focus of your analysis, your investigation, you may only look at safety-related harm, injury, death, loss, and damage and loss of property. But you might also want to think more broadly about that environmental aspects and also damage to your business and cost of insurance in the future. In terms of hazards then, so the main hazard or hazards in this situation are to do with collision. So collision is the ultimate outcome, if you like, but the hazard associated with collision is before that harm occurs, before that event occurs. So we're looking at a state or an event associated with loss of safe separation and or trajectories that lead to loss of safe separation. And you'll notice there that, I mean, it's a bit scribbly, and I do apologize. Maybe I should have, written it up a little bit more. But in the interests of, getting this out the door and, helping you understand more about CAST, we need to think about the concepts of trajectories that lead to loss of safe separation, and think about, as I said earlier, about the concept of control. Who or what is in control of safe separation? Well, it's distributed amongst the control structure. You've got the crew of the Navy ship and the crew of the Filipino ship. And they control safe separation by steering the ship and by controlling the propulsion. And then the trajectory is obviously related to that as well. So we're talking about movement and trajectories leading to loss of safe separation, and then the loss itself, collision, and then the other potential, so sinking, death, damage, all the other good stuff. So what's the high-level safety constraint associated with that hazard? Well, the main one is to do with the movement and trajectories. So the control structure, the hierarchical control structure, the HCS, hierarchical control structure, shall prevent, I can't spell, what's that? Shall prevent movement and trajectories that lead to a loss of safe separation. So straight away, we know now what the high-level safety constraint was that the control structure did not adequately enforce. So it did not prevent movement and trajectories that led to a loss of safe separation. So our whole purpose of CAST analysis here is to establish what was the control structure and why did it not prevent movement and trajectory that led to a loss of safe separation. That's the aim of the investigation. There is another related high-level safety constraint that is to do with the HCS shall provide protection, resilience to the collision or sinking. Now that's interesting because that's not directly related to the collision itself or to the cause of the collision, but there may be other things we can learn about how the protection and resilience behaved and performed in this situation, and maybe identify other requirements that might benefit other ships in the future. And then the third one is the HCS shall provide an emergency response, rescue and recovery capability. Now you'll notice that the second and the third one are related to, well, we've had a collision, now what? What controls, what mitigations, what benefits do we need to prevent the loss of life or further property damage or loss? And also, when we talk about the control structure shall provide whatever it is, we're not just talking about somebody on the ship, one person, driving the ship or whatever. We're talking about the system itself, the overall system, and how those different layers of hierarchy actually contribute to safety. So safety is not just, well, there's the cliche safety is everybody's responsibility. And yes, I suppose it is, but the responsibility is specific to them at the level of hierarchy that they have. So if, for example, the higher level of the hierarchy doesn't provide ships that meet minimum standards or that meet standards that are not appropriate for this kind of collision, then there is a question there to be considered. And also in the context of the emergency response, rescue and recovery capability, if you're operating in a particularly dangerous area, for example, maybe that that situation, that state, should actually change or evolve the control structure for the emergency response, rescue and recovery capability. You know, maybe there are extra things that are needed for different contexts. And then finally, the control structure shall provide an ability to learn from an accident and make improvements. So I'm just really sort of pointing home that any system needs to have a control structure that has some form of feedback loop, so that if there is a near miss or an accident, we can learn from it, and that learning gets embedded, into the control structure. So we improve. We don't just keep having the same accidents over and over again. And I suppose this is where I'm sort of coming from with this picture. I'm really talking about this green feedback loop. So if you do have a near miss or accident, are we investigating it as best as we can using the most effective processes? And this is why I'm pushing CAST stamp so much, because I believe it is, you know, a leap forward in advanced analysis that will give us, you know, better learning, more opportunities for improvements to improve safety and prevent accidents and losses of missions and pollution and all the other good stuff. But are we actually looking at that feedback loop? Are we actually learning what we can? Is that learning process, investigation process effective? And are the recommendations from that investigation process actually making a difference? Is the organization management actually doing something, you know, actually paying attention and making appropriate changes? Or are they just, well, let's just get back to situation normal. You know, accidents are accidents. We'll deal with it if we have another one, but let's just keep going. Situation normal. So is that control structure adequate to prevent future accidents? And I suppose this also leads on to the point I made earlier on. There was another very similar accident from what I am aware. I don't know the detail, but from a high level perspective, there was also another US Navy ship. I think it was the USS John McCain. They had another collision at sea. I think it was 6 or 8 weeks after this one. So are there any common, you know, issues with the organization management, design and operations that are common across both of those accidents, those collisions? I'd be certainly interested to find that out. Okay, so we talked about losses, we've talked about hazards, we've talked about high-level safety constraints. Just one more thing about high-level safety constraints. So to keep it simple, I'm only going to focus on the first one, which is the control structure shall prevent movement and trajectory that lead to a loss of safe separation. So I now need to model the control structure related to that high-level safety constraint. If we're doing a proper full-on investigation, we may also look at the other three as well. But as I say, I'm not intending to do that unless something obviously pops out. So yeah, that's that bit. Right, so just bear with me a second. Let's have a look, pause. Yay. Right, so then, let me share that again. Right, okay, so you should now be seeing a screen that has the report on one side, and so liquid text on the left with the report in it, and then on the right is good notes with my PDF scribble notebook on it. So as I showed you in the slides a while back, I've got these worksheets, which is this on the screen, and they're A3 sized for convenience, for his and hers pleasure, as the saying goes. And so the stuff we've just talked about, losses, hazards, high-level safety constraints, I would have scribbled them in there. I'm not going to, because I want to save time, but that's where I'd normally do it. In terms of facilitating the analysis, I include what's called a log of, well, a couple of things really. The first is the physical items that are relevant to the control structure, relevant to the accident, the components or candidate components that I expect to appear in the control structure. So you can see here on the left-hand side, these two purple things I've highlighted, the US Navy destroyer Fitzgerald and the container ship ACX Crystal. I would list them here at the bottom on this page because they're likely to appear in my control structure. In fact, they most certainly will do. But as you're going through and learning about the report, learning what's in there, you might identify components that you think might be relevant to your control structure, like the AIS, the whatever AIS stands for, something information system, automatic information system. Yeah, that might be relevant as a candidate component for my control structure model, but only as I start to learn more information about it, it might actually, it's irrelevant, or it's relevant in a certain level of detail, but not for the overall control structure. And then also physical items. So for example, and I don't think it's relevant to this, but the navigation lights, if that's what they're called on ships, the anti-collision lights, anti-collision beacons from an aerospace perspective, I understand that the ships have a series of lights and they mean certain things and that they're visible from certain sectors of approach, like from the port or starboard side. And there may have been lights that were failed, for example. And so I'll list the lights if it's relevant. And then if if there's a problem with them, I'll analyze that in the physical analysis. So this is really just a list to capture things for onward use if necessary. And it really helps to lessen the load on the old brain there. But of course, as we're going through the investigation, we might identify genuine questions that we want to answer, as part of the investigation, or that we expect will be answered later on, such as the AIS. Why was the ship operating without the AIS? That's a valid question. I want to know the answer to that later on. It should be in this report. I hope it is in the report, but that's certainly something we need to think about. The other thing as well is to think about unanswered questions, UAQs. So there may be things that we want to ask, but we can't, because obviously we're not part of the original investigation and we can't ask those questions, but we need to be aware of those because it may be, in future investigations, we might want to answer those, or even better, for improved safety in the future, we might want to put some action together to go and answer those questions and make recommendations for them. So it's important to capture those and recognize that as the investigation progresses, as the analysis progresses, you may answer those questions or not. And then the same goes for recommendations. So when you're going through it, you might think we need an immediate recommendation for this, this, and this. And so they're obvious recommendations and they need to be made, either to stop operating or do something different. So you need to capture those. But there may be other recommendations that you want to make, but the subsequent analysis actually shows that the recommendation would not be beneficial or might actually cause other problems. So it's important to capture all the recommendations and candidate recommendations, and then be mindful how those recommendations might be implemented and whether they'll actually benefit and reduce the likelihood of a future accident, or eliminate it, or potentially cause other accidents that didn't occur on this particular occasion. So yeah, just capture those, just keep a track of them. It really helps. So yeah, so from a modeling perspective, I've highlighted, well, two things. The first is about the timeline and the control structure. Obviously, this is one page. You might want to, do it on more than one page, just copy and paste it. But to be mindful as well about the control loops. So think about the level of detail, the abstraction you're looking at, whether it's actual loops, jigsaw pieces, or broader across the control structure, the jigsaw puzzle. And then also just be mindful of this. So think about the physical process, the control process, design, operations, maintenance, and response and recovery. If you're investigating an accident in a, flight test or some kind of test or evaluation situation, obviously you'll need to add that detail and think about it here. Investigators, how they fit in, and the perspective of the investigator. So one of the things I always like to sort of emphasize is when you're doing your investigation, you need to get into the mindset of that you're stood on the outside of the system, the control structure, and you're trying to understand what it looks like and how it all fits together. And so you're on the outside of the system, you're on the outside of the control structure. Well, then when you come to do the analysis of the components of the structure and the structure itself, you need to step inside the structure and almost take on that role to try and understand the context, try and understand what was going on. And of course, you'll need subject matter experts support as and where required, but just be mindful of your mindset as an investigator, your mental model, your algorithm. Stand outside the control structure to model it, and then when you come to do the analysis, step inside the control structure. And yeah, the other thing as well, I've already sort of touched on it really. Think and recognize where you are in the system lifecycle. Because clearly, if you're doing an investigation, you've already got an operational system, and so you'll conceptually be inside the operations service part of the lifecycle. But don't forget to think, focus on that to start with, but also think more broadly. Think about changes, think about commissioning, the creation or manufacturing or building of the system, the design and development of it, perhaps even the concept. And if you're talking about business opportunities, perhaps even the opportunity itself. Now, obviously, this is very broad and high level, and maybe I'm going on a bit too much, and I should put this in some formal paid-for training. But just think about that. You're in the operations phase. Think more broadly what other parts of the control structure might be relevant to this situation. And then analysis, component analysis, talked about control actions, and then the structure analysis. So that's sort of where we are. And I'm just looking at the clock. What time is it? 9 o'clock. Are there any? Oh, there we go. There's a few people commenting there. Hi, Christoph. Mauritius. Yes, that's right. Mauritius, not the Seychelles. Thanks for that. I doubt there is any safe separation in maritime context. Everything avoiding the collision is good. Yes, that's a good point. Thanks for that, Christoph. Yeah, okay. So are there any questions, comments, concerns? I'm just looking at the time. It is getting a bit late, and I probably could do with some beauty sleep. What I think I'll do is come on and do another live stream and capture the rest of the stuff that I'm doing. Because I'm getting a bit coarse now. Coarse. Okay, well, if there's no questions, that's fine. Let's just put this back on the screen. That should come up on the screen now. Yeah, so as I said, if you're not already a member of my email list, please join my email list at systemsafetywebinar.com, where I'll make you aware of future training and coaching. As I said, this work is the foundation for my upcoming masterclass on CAST in the maritime context. Excuse me. I think it would be a good opportunity. It's quite good doing the live stream. I think I should perhaps do some more. I don't know what you think. Please comment below, like, share, and subscribe, and all the other good stuff. But as I say, register there. I'll make you aware when the masterclass is ready to go, ready to register. And I look forward to seeing you on the next webinar and also on the masterclass. Thanks very much for watching. And remember to like, share, and subscribe. Have a good night.